Welcome to qnawire.
Okay, so this is the force diagram for the roller. So let's take a look at the moment about point O. Consider counterclockwise moment is positive, clockwise moment is negative. And this will give us FB times 15 millimeter minus FC times 15 millimeter is equal to 0. Therefore, have FB is equal to FC. FB here is the friction at point B, FC here is the friction at point C. So since we consider the system is in equilibrium, since the roller does not slip, therefore, we have the net force along xy direction is equal to 0. So we have the net force along x direction is equal to nc sine theta minus fb minus fc cosine theta is equal to 0. So we have fc cosine theta is equal to nc sine theta minus fb. nc is the normal force at point C. And then the net force along y direction can be equal to nc cosine theta minus fc sine theta minus nb is equal to 0. So we have fc sine theta is equal to nb minus nc cosine theta. And we know nb here is the normal force at point B. And remember, since mu b and mu c is equal to 0.3, therefore have fb is equal to fc, which is equal to fb over mu b, and then fc over mu c can be equal to fb over mu b. And this will give us nb is equal to nc, which means that normal force at point B should be equal to normal force at point C. So now we can use nb substitute for nc and use fb substitute for fc. So this will give us such equation here, which is fc cosine theta is equal to nb sine theta minus mu b nb, and this is equal to nb times sine theta minus mu b, and fc sine theta can be equal to nb minus nb cosine theta. So we'll have fc sine theta is equal to nb times 1 minus cosine theta. So now we can set such equation here, which is fc sine theta over fc cosine theta is equal to nb times 1 minus cosine theta over nb times sine theta minus mu b, which is equal to 1 minus cosine theta over sine theta minus mu b. As you can tell, fc here can be cancelled out, and nb here can be cancelled out. And this will give us such equation here. So now we can multiply by length cross with each other. So we have sine squared theta minus sine theta mu b is equal to cosine theta minus cosine squared theta, which is equal to sine squared theta plus cosine squared theta minus sine theta mu b equal to cosine theta. And we know sine squared theta plus cosine squared theta is equal to 1. Therefore, we have 1 minus sine theta mu b is equal to cosine theta. So now we can put square on each side. Oop. And this will give us 1 minus 2 mu b sine theta plus sine squared theta mu b squared can be equal to cosine squared theta. And we know cosine squared theta can be equal to 1 minus sine squared theta. So now we can use 1 minus sine squared theta, substitute for cosine squared theta. And this will give us 1 minus 2 mu b sine theta plus sine squared theta mu b squared theta. I'm sorry, it's mu squared b, okay? And then equal to 1 minus sine squared theta. And then as you can tell, 1 here can be cancelled out since both sides has 1. And this will give us such equation here. And this can be set up like this as well. And then we can cancel out the sine theta on each side. Also the negative sign. And this will give us 2 mu b minus sine theta mu b squared is equal to sine theta. So if we do some arrangement here, eventually we'll have sine theta is equal to 2 mu b over 1 plus mu b squared. So we know the coefficient of the static friction at point B is equal to 0.3. So now we can plug in 0.3 for mu b. So eventually we'll have angle theta is equal to inverse sine 2 times 0.3 over 1 plus 0.3 to the power 2. And this will give us the largest angle theta can be equal to 33.4 degree. And this is the answer for this question.